the previous class, we talked about thermoplastic. Okay, so we learned the thermoplastic is basically the polymer that can be melted and reshaped again and again. It can be melted and reshaped again and again, again and again. So that is basically the characteristic of thermoplastic. We learned in the previous class there are like many thermoplastic like PP, polypropylene, PVC, and then what else? The high density polypropylene, polyethylene, polypropylene, and then what else? The polyamide and so on. So that's what we covered in the last class. In today's class, we will talk about the thermosets. Okay. Today's class, we talk about thermoset. Okay. So what is thermoset? Thermoset is basically a polymer. Okay. It's basically a polymer. It's basically a polymer that form irreversible chemical bond during its formation. Okay, so that is one of the definition of thermoset. Is a polymer that form irreversible chemical bond during its formation. This irreversible chemical bond, they are the term for that. We call it crosslink. And also during its formation, there are also term for that. We call this curing. Okay. This irreversible chemical bond that is made during the formation of thermoset is covalent in nature. So this is covalent in nature. Meaning that if the thermoplastic like this, if the thermoplastic like this, the thermoset will be like this. Thermoset will be like this, but they have what we call the link, the cross link between the polymer chain. So you have this thing, something like that. It's a network polymer. We learned before one of the classification of the polymer based on the molecular structure is whether it's network, branch, and so on. Like. So this is thermoset. You have this thing. You have this what we call the linkage. We call it cross link. And this linkage, this thing is a covalent bond. Between the thermoplastic, if you see here, the thermoplastic here, between the thermoplastic, it is what we call, there are no covalent bond in between the chain. They just have a covalent bond within the chain, but not interchain. Okay, so that's the difference between the structure of thermoplastic and thermoset. And because of this covalent bond, this thermoset cannot be melted. Okay, this thermoset cannot be melted again after initial forming. Meaning that you make a thermoset, you get a shape, and then you cannot melt that again. Okay, you cannot reuse again like a thermoplastic. Okay, so that is what we call the generic idea about what is thermoset. And thermoset typically, because of this covalent bond and also this network structure, thermoset typically hard. Typically, it's hard and rigid. Due to this what we call this network linkage and so on. Okay, so it become permanently hard lah. Okay, it become permanently hard during formation. So this differ than thermoplastic where you can remelt again and again. So to give you the example, let's see this thing. I bring here. Let's say I have this thing, what we call the flame, and we have seen this before, the glue stick. Okay, the glue stick, and this is the kitchen sponge. Okay, the glue stick, as you learned in the previous class, is thermoplastic. Okay, you can melt it, and then after it's melt, you can see it's hardened back. Okay, so this in blue stick here. So in blue stick, let me put here. In a glue stick, okay. So the glue stick is basically the polymer that make this glue stick. We call it EVA, EVA or ethylene vinyl acetate. So this ethylene vinyl acetate is basically a co-polymer lah. So ethylene, you know the ethylene is like this, right? Ash, 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 like that. And then the acetate, so this, let's say I put like this, so I put like this. Okay, let's say this is ethylene, you know this thing, ethylene. And then the what we call the vinyl acetate, this part is this thing. CC, ash, ash, the O, and then this is apa? So this ash, this is CO, and then CH3. So that is this is M. Okay. So as you can see, this is what we call co-polymer. Co-polymer, meaning that inside the polymer chain, you have two distinct things. For example, let's say this is red. Let's say this your chain. You have this here, this here, this here, and then suddenly you have this acetate part, and then you have this thing, and so on. This is what we call co-polymer, meaning that you have a distinct repeat unit in one chain. If you look for what we call polyethylene terephthalate, the one that we learned in the previous class, the PET one that we learned in the previous class is a little bit different. So this PET, thing like this, right? I remember how this thing. I don't remember how the structure looks like. Can anyone check the? Oh, I can just here. Let me check PET. PET poly. Okay, let's say polyethylene. Okay, polyethylene terephthalate. Wait, Control C. Control V. Sekejap. Too much. Ethylene terephthalate. Okay. So you can see the structure for polyethylene terephthalate is more or less like this. PET, that thick. So you can see this is one monomer. Okay, so that's thing. So let me go to image. Make sure that you can see much more clearly. Okay, so you can see here, you have this part and also you have this part, but it's in one repeat unit. The difference between the copolymer is that this thing doesn't attach with this. So you have, for example, this by itself and this by itself. Okay. For the EVA, the amount of this, what we call the acetate, the vinyl acetate, is around 10 to 40% lah. And then the rest is ethylene. So you can see the difference between this copolymer, the polymer that have distinct, what we call, is as if there are two polymer fused together in what we call in one chain. But for that PET, even though you see there are two things, there are this terephthalate part, and then this is ethylene part, but this ethylene and terephthalate merge together. So the repeat unit is all distinct. But for copolymer is distinct. So this is made of the what we call EVA. Made of the EVA. Where is the rubber? Okay. So we know before in the previous class, this is what we call the thermoplastic. Example of thermoset is this kitchen foam. This kitchen foam. This is made of what we call the kitchen foam. Kitchen foam. This thing is made from the what we call polyurethane. Polyurethane. Okay, or PU, we call it PU lah. Okay, so this is thermoset. Okay, if you try to burn these two things side by side, you will see that this thing will melt. So for example, as you can see before, if I burn this thing, it just melt, but it takes a little bit time lah. So it will melt. So you can see it will melt. And but if I if I burn this thing, oh, I don't have this. Okay, it burn. Okay, it's not melt. It just burn like that. It just burn like that. Okay. Okay. So as you can see just now, when I try to heat this up, it takes longer time to melt than this what we call the kitchen foam. Does this mean that this thermoset have lower temperature tolerance than the thermoplastic? The answer is no. The answer is no. Thermoset, because of 3D dimension network, typically thermoset, one of the properties of the thermoset, one of the properties of thermoset is that thermoset, it had high temperature stability, meaning that you need high temperature in order to burn this. Remember, thermoset doesn't melt, it burns. You need high temperature to burn that. But as you can see just now, it takes just a few seconds to burn this thing. Even though this is thermoset, it takes just like a flip of second to burn this thing. This is happened not because of the thermoset itself, it's because of the structure of this kitchen foam. This kitchen foam is what we call is made of like a tiny, it's like a foam lah. So the surface area is high, so that's why it can react very fast like this. It's similar when you have like a block of what we call metal. For example, let's say I have a block of metal and like this, and I try to hit it, it doesn't budge, nothing happens. But if I make this metal smaller, for example like this metal wool, I can just, it's same thing, it's a stainless steel, this also stainless steel, this is stainless steel wool, this is stainless steel rod. The same thing, but when you change the structure, it's easily burned. You can see it's easily burned. So the thing is not because of the metal itself. Metal have high melting point. But if you make the surface area high enough, like this is stainless steel, but you can simply what we call burn it like this. Okay? So structures matters. That's why we have this nanomaterial and so on. One of the key advantage of nanomaterial is that it reacts faster. So for example, if you have nanomaterial and non-nanomaterial, if you want to check in terms of what we call speed of reaction, for sure the nanomaterial will, what I call the reaction that happen for nanomaterial is much faster lah. It's like you have a sugar cube and the sugar powder. You make a coffee, you know that the cube will dissolve smaller. So that's the reason why this burn up very fast. It's not because of the thermoset doesn't have high temperature stability. In fact, thermoset have very high temperature stability. It's just because this is the foam. It's not like dense, like what we call like the glue stick that you see just now. This is not the foam. It's a very dense solid. That's why it takes a lot of time to burn it, to melt it. But in general, thermoset have high temperature stability lah. Okay, you can sort of like make analogy. The thermoset, let's say this thermoset is like you want the analogy. The analogy for thermoset is like you make the egg. You make the egg in the what I call in the house. You have the eggs and then you try to fry the egg. You shatter the egg and then you put on the what I call frying pan. The egg become like this and then you cannot revert back to the normal egg because the egg like this, right? And then you crack it and then you make the egg telur mata. So this, you cannot go back to here. So that's the analogy for thermoset. The analogy for the thermoplastic is like the ice. You have the ice cube, and then you melt it, you get water, and then you can put this water back into any other mold. Maybe you want to make a mold like love, and then you put the water inside this, and then you get what we call the love ice cube, like that. So this, you can see, you can melt and remelt, and this you can remelt again and remelt again, and so on. So this is what the idea of thermoplastic. You can remelt it again and again, and also because you can remelt it, you can reshape it to whatever mold that you want to put into lah. But thermoset is like you take the egg, you fry the thing, it becomes like this, it cannot get back into the original egg. Okay, so that is the analogy for the what we call for the thermoplastic and thermoset. So that is one of the advantage of not advantage, advantage lah. Some people said this advantage of the thermoset because it cannot be remelted again, so it can retain its structural integrity for long. If you have two same root, same diameter, same density, and so on, one is thermoplastic, one is thermoset. If you hit this thing will start to what we call bend or layo over time. But this, it will just stay rigid like that until it burns. Okay, so it stays just like that if you have two root like this lah. The one that I showed just now is not apple to apple comparison. You compare this thing, a dense solid, with the foam. So you cannot make what we call just comparison lah. But if you have two root, same diameter, same density, but just this is thermoplastic and this thermoset, when you heat it, it becomes like this lah. This will sort of like melt like that, and this will retain itself until it reaches one temperature, then it's burn or break down lah. That's why you can see here, burn or break down, meaning that it break lah, it degrade. Okay, because after melting, you have degradation temperature. The temperature where the molecule itself break down and so on. That's why you get the black thing. Okay, so that's one advantage of the what we call of the thermoset. Another advantage of thermoset is that typically when you want to make the thermoset, you start with the liquid. Okay, many thermosets start with the liquid form. Okay, so like this, liquid form. Start with the liquid form. So this is a resin and hardener. So, but before I discuss that, I will ask Farah to come in front for a while to help me to set up this thing, because I want to show you how people make thermoset. Anyone have played with this before? This is the resin. People use it for make a resin art and so on. So, but because those at the back cannot see it, so I will ask Farah to come in front here. Sit here, and I will connect with the laptop. So as usual, so let me open the camera first. While I'm demo this thing, I will explain something. So let me open the what we call the camera. Okay. So that is me. Okay, so you see, okay. So now, how people make a thermoset? Typically, thermoset, they make it from the liquid. From the starting precursor is the liquid. So this is one of the properties of thermoset, one of the advantages. Another properties of thermoset, generic property of thermoset, is that it got low viscosity. Low viscosity meaning that because thermoset the starting of thermoset typically a liquid, so you can sort of like use this easily to put into a mold. So easy to mold. Okay. For thermoplastic, normal thermoplastic like the chair, like whatever what is plastic that you have here, the chair or glue gun here, they come from not the liquid. Normally, when people, they come from liquid, they can make liquid. But typically, when people want to make a chair or this glue gun, they use what we call the pellet. Okay, they are factory. pellet. So let me put first this thing, the origin of the thermoplastic. Pellet. For example, let's say you want to make the plastic bottle, this plastic bottle, this thing. Let's say you are a factory, you want to make this PET. So how you want to make that? You have the PET pellet. So that's pellet. So that's thing. So you buy this pellet. The pellet is like a granule like that, and then you heat it. You need to heat it so that it become melted. Okay. Once it's melted, you can put in the mold, and then you get whatever you want lah. For example, that bottle is made from the PET. So how they do it? They take this pellet, they extrude it, meaning that they blow it, and then they heat it. So you get that bottle lah. So the key is that for the thermoplastic, normally you need heat. You need heat in order to make the pellet become liquefied, and then only then you can put into mold. You get something like a chair. You have this, let's say this chair made from the HDPE. You find the HDPE pellet. You buy this, normally the factory buy it. So they buy, and then they heat it, and then when heat it become liquid, and then it fill the mold. So you need heat, and normally in order to, to heat this thing, the temperature is around 150 and above like that lah. To melt all this thing, the melting temperature. So you need a temperature, heat, which is energy. So it's a little bit messy lah. But for the for the thermoset, normally they start off with the liquid. The starting the starting material to make a thermoset usually like this liquid. Okay, so this one is the resin. This one is the is the hardener. Normally they have, if they make from the liquid, they have the resin, and then they have the hardener. Normally the epoxy, when they use the two type of the material like this to liquid like this, usually the thermoset is called two type curing thermoset, whatever lah, thermoset. Okay, normally they give the name epoxy lah, epoxy like that, epoxy. So for thermoset, one of the example of thermoset is epoxy. One of the example of thermoset is epoxy, and normally epoxy come in two types. You have the resin, you have the hardener, and these two things come in the liquid form. In order to make the epoxy, you need to combine this together. So that when you combine this together, the cross-link will happen, and then it will become sort of like hard lah. It become hard. Cross-link happen, so this cross-link happen, and then it become hard. So there are no heat involved here, no external heat involved here. Of course, during the reaction, the heat is produced, but there are no the outside heat that you need to use, like the melting the thermoplastic in this case lah. So you can see here we have two things. So normally the manufacturer will give the ratio lah, how much this to add to this. Okay, this is hardener, this is the resin. Okay, so when you mix this together, the crossing will happen and we become harden lah. So this resin, this specific resin, specific epoxy, you need three part of this and one part of this in order to make a perfect epoxy lah. So that's normally you can read it in the manufacturer description lah. So in order to get the ratio, it's not about volume. Normally people don't combine this based on the volume, but based by the weight. Okay, so you need typically this scale in order to weight the thing to get the ratio, because the volume change depend on the density of the liquid. Okay, something have low density, something have high density. So the volume, even though you want to get 1 liter for A, 1 liter for B, if the density is different, boosting, the volume will be different because the density is basically have some relationship with the volume. So that's why in order to measure this thing, you need to use weight. Okay, okay. So I have this thing. So let's say I want to make a mold out of this. I want to make a mold out of this. So what you do is that you put here. Can you show this thing? Okay. So basically, you put the thing, put atas thing. So this, you need 3 parts of this. So what you do is that 3 and 1, let's say I want to do 40 ml. So 30 ml this, 30 ml here, 10 ml here. So that because roughly 30 ml is 30 gram for this material. So you can just tear this thing. Can you see? Tinggi sikit, tinggi sikit. Okay, so basically you need to make sure you put 30 lah. 1, 2, 3, 4. Okay, 30.8. Okay, so you get 30.8. So basically I need to add around 10.8 of this hardener in order to what we call to make it cross-link. By itself, it doesn't harden. But when you add this thing, it will harden. So that is 31. So I need to add. So you can see here. Can you focus here? So this is 31. I don't know whether you can see or not, but this is 31 lah. So I need to put until the total volume is becoming 41 lah. So I add the what we call the hardener here. So I just hardener there until 41. The thing is, if let's say you don't put it a correct ratio, then there are not enough hardener and resin to what we call to react with each other. So you end up with the epoxy that is not cure perfectly lah. So now once you add like this, the reaction start to happen lah. So normally you need to mix it to what we call to promote the cross-linking to happen lah. So I have this popsicle, and then I what we call, I sort of like apa ni orang kata, swirl it slowly and gently, because if you do it very quickly, what will happen? The bubble will be formed. Okay, when the bubble form in the, because remember this is not like water, this is like honey, it's viscous. So if you try to sort of like kacau, stir very fast of the viscous liquid, the bubble will form. So when there are bubble in the thing, and if it's cure, you will get something like this. Sample that is already cure, hard, but then there are bubble inside. This bubble is basically made of air. They are air. So this air, this air, this air, this air. So this bubble will act as like a weak link in the entire structure. So because there are no solid here, so it's weaker here lah. So it can promote crack and so on. So it will sort of like compromise the integrity of the cured epoxy. So that's why you need to sort of like do it slowly like this. So when you do like this, basically what I did is that I try to react the hardener and the resin together lah. So as you can see, it's not hardened yet. The reason because it's depending on the epoxy. Some epoxy can harden very fast, some epoxy can harden very slow, depending on the manufacturer lah. This takes 20 hours to harden. Okay, takes 20 hours to harden. But if you have something like this, if you go to the Mr. DIY, you see something like this, right? Have you ever seen something like this? Mr. DIY, it's like a glue, but there are 2 parts. Normally you are used to this, what we call super glue. Super glue also Thermoset, but I will talk about this later. But this also epoxy. But this epoxy, the one that you see in DIY store, this one, the specific one here, they can harden in just 5 minutes. Meaning that the same idea like this also, you take something, for example, let's say I have this paper, and then I put this thing, and then you need to make sure also the same thing. This one, if you look at the what we call at the description here, they say that in order to make the epoxy, you need to put the ratio 1:1. Here, 3:1. So different epoxy have a different ratio based on the manufacturer lah. So if I put here like this, you need to put like that, and then this just because it's just DIY, so don't need to be very precise, but you still need to make sure that both of these have the what we call more or less the same size or weight lah. And then same like that, you have to what we call to normally for DIY they give you together with this thing, the stirrer, and then you do like this. Okay, after 5 minutes, this will be very hard lah. Okay, and then you can make a glue anything lah. It's much stronger than the typical glue that you use lah. For the the aeroplane wing, they don't attach the aeroplane wing with the this aeroplane wing. They don't use the screw here. They normally use epoxy, okay, to attach here and there lah. So here, if let's say I forget to take the stirrer, it will harden and it's very hard for me to take it out. If let's say the epoxy, you make the epoxy and then some of it, what we call, left on your hand, like this, then you cannot pull out. You need to what we call cut like that. Or you need to sort of like find the abrasive and then remove the thing. Okay, the normal glue doesn't do that. Even the super glue is not as strong as the epoxy. Okay, so this. So you can see it's already what we call quite become more viscous. So this, from this until it become fully hard, we call it pot life, P-O-T-L-I. So you have the epoxy here, you have resin, and then you have the hardener. You add together, so you have the pot life here, meaning that the duration it takes when you can still sort of like play around. For example, let's say you have something you want to glue together. If this is become very hard, then it's hard for you to transfer this to whatever thing that you want to glue together. So the moment, the duration where you can transfer or play around with the epoxy, we call it pot life. Okay, pot life. So after certain moment, it's become so viscous. It becomes so viscous, then you cannot sort of like reuse that. Meaning that you cannot transfer it here and there. So we say that it's already past the pot life. When it's already what we call hardened fully, we call it fully cured. The term is cured. Okay. So this specific epoxy here, the manufacturer said that it takes 5 minutes in order for this to fully cure. Fully cure also we can, the other term for fully cure is set lah, set. It takes 5 minutes for this when you mix to set. So you need to do all your stuff before under the 5 minutes. Okay. So if I forget to take this stirrer, it will attach to this lah. So I need to take it out lah. Take it out and put here. So here, once you get something like this, so the idea is the same like this lah. So once I got all this thing like this, this is still liquidy up until now. Compared to this, it's become more viscous, or the viscous. So this, it have what we call it will cure in 20 hours, in 1 day. So once you get something like this, what you do, you can make what we call, you can put a mold lah. Can have any mold, and then for example, you put inside the what we call, inside the plastic like this, and then you just pour lah. You just pour like that. Okay, pour like that. Whatever you want to put inside. And pour like that, and over time, this after what we call 1 day or 2 days, so you can take it out lah. You can take it out. So you get something like this. So you can pass around. Okay, so this is epoxy, the one that people use normally for what keychain and so on. They use epoxy because it's hard. Okay, pass around. If let's say, thank you. Siapa nama Farah? I will detach this first. Okay, thank you, Farah. You can just put there. Okay, so that is basically the what we call the silap. Okay, so that's basically the epoxy. If let's say the ratio is not right, for example, you mix this with the incorrect ratio, what you get is something like this. Okay, so I have these two things. These two things also epoxy. One is mixed with the correct ratio. One is mixed with the incorrect ratio. The one that is mixed with the correct ratio is hard. It's hard. It's very hard. Okay, it's very hard. The one that is mixed with the incorrect ratio, you can see it's easily bent like that. So it's not fully cured. It's not enough hardener or resin to sort of like to react with each other. So you can pass this around, so you can see the difference between these two lah. You can see this, the color is quite what we call quite yellowish, thingy and so on, because I don't know, this hardener is already old one, so it become like yellowish. You can find very clear one if you buy a fresh, then you get a clear one lah. But anyway, still okay for that. So you can pass around and you can feel the thing, what happened if you don't mix the ratio correctly. So as you can see, one of the advantage of the what we call the Thermoset is that it got low viscosity, like this, low viscosity, and then it allow you to mold easily. So if let's say you have mold like this, you can just pour it. For thermoplastic, you cannot do that. Thermoplastic, you need to heat it. You need to heat it until it melts. So you need temperature to what we call to melt it first before you can mold. And that's and it becomes it's very viscous. It's like this what we call, where is my this thing, glue stick. It's like, imagine this is thermoplastic pellet. If you try to heat it, you can see the what I call the melted plastic is very viscous. So when it's very viscous, it's very difficult for you to mold into this thing. Like this is easy. If you have Thermoset, it's easy. You just pour like this easily. This is less viscous. Okay, so you can assume the shape easily. But if you have something that is very viscous like honey, it's very difficult lah. So one of another advantage of Thermoset is that typically it start with the liquid, and because the liquid have low viscosity, it's easy to mold lah, to put into the mold. Okay, so this what we call here curing. This is curing. Let me take this thing. Where is my another this thing? Okay. When it start to harden, it's called cure. For example, this already cure or not? Let me check this thing. Okay, it's already hard. It's already a little bit hard lah. Little bit hard here. Okay, so it's already near to the curing time. So you can cure the epoxy. You can cure this thing. We call it cure. Cure using what we call chemical reaction. Chemical reaction. So the one that you see just now, when I mix this together, the cross-link happen. That is curing using the chemical. You can also cure using the heat, meaning that you add heat. You can also cure using UV. Okay, so there are epoxy that can be cured using UV. For example, this epoxy, this one is a UV. If you look here, it's a UV-led resin, meaning that instead of using hardener, because here this is resin, this is hardener, you need hardener to make it hard. Here, you only have resin, and the UV act like a hardener. So if I take this and I put here, alah, Farah dah duduk. So I put here, sini lah Farah sekejap. Dia duduk sini, sekejap je. So, yeah. Okay. Okay, let me put here. Okay, ni sekejap je ni. Okay, okay, that thing. Okay, okay, you just put here because I want to put here. Okay, if you look here, this is a UV resin. So if I put in two places here, let's say I put here, and then I put here, so you can see it's quite. Can you see or not? Not really. Here. So you can see this liquid. It's a liquid, right? It's like a resin lah. It's a viscous liquid. But one, if I, for example, if I take UV and shine on that, it will be cured straight away. So for example, here I have these two things, and I will cure this thing with UV light. This is UV light. So if I do here, I do like this, blah, 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 like that, the reaction happened already. Okay. So if I take this, it seems like nothing happened. But if I take what we call the popsicle, if I try to put here, you see, it's still wet, right? It's still wet. But here, it's already hot. It's already hot. It's already hot lah. It's already hot. Okay. So that is basically another type of UV, another type of epoxy where it can be what we call, it can be sort of like cured using the UV. So you can cure the epoxy with many things, either with chemical reaction, heat, UV, and sometimes you can what we call cure it with what we call moisture. Sometimes you can also cure it with the moisture. Example for this is your gum gajah, this thing lah, the super glue. The super glue is basically is the epoxy. We don't call it epoxy, it's super glue. Super glue is basically made from the cyanoacrylate. So basically this thing is also set or cure, but this cure based on the moisture. So that's why when you have super glue, you put it somewhere here, like here, and then you let it for a while, it will harden because around you in the air there are moisture. And that's also the reason why super glue, if you don't close it very tight enough, you will see it's very hard to, it's just set like that because it's cured due to moisture, and around you there are a lot of moisture. So this is also thermoset. This also thermoset. This also thermoset. Thermoset. So we see how many examples of thermoset? We see super glue. We see the epoxy. This epoxy, epoxy, super glue, and also the polyurethane. So 3 examples of what we call of the thermoset. Okay, so in general, we can say that 2 advantages of thermoset over thermoplastic is that first, it have high temperature stability. So if you want to make a plastic that can survive high temp, then normally people goes for what we call for thermoset. Secondly, because thermoset it start with the liquid normally, then it's easy for molding, and in particular for the epoxy, the what we call the viscosity for the resin and hardener is very low. When you when you try to sort of like what we call mix them together, you get something that is free flow like this. So this allow the resin and hardener mixture to fill in a crevice, a nook and cranny of your mold. So if you have a very complex mold, then it's much easier to use epoxy, to use thermoset plastic compared to using the thermoplastic. Because thermoplastic, you need to melt it first in the high temperature, and even after you get melt, it's very viscous. So it's hard for that to flow in the what we call in the nook and cranny in your mold lah. So so that is 2 advantage or 2 properties. We can say advantage of thermoset lah. 2 advantage of the thermoset over the thermoplastic. But the disadvantage of the thermoset is that you cannot recycle lah. Once you get that thing, the one that I passed you through, you cannot remold it again. It's done. You cannot just break it down or what we call heat it up and get the thing again. So it's just set like that. So that's disadvantage lah. Under the thermoset, we have car tires. See? Car tire. Car tires. Car tire. Car tire also thermoset. Thermoset. Okay, car tire also thermoset. Okay, you know the car tire is made of rubber, right? Made of rubber. Rubber by itself is a natural polymer. Normal rubber, the one that you get from the tree, is a natural polymer. But in order to make a car tire, you cannot use a natural rubber. This is natural rubber, natural rubber. You cannot use a natural rubber from the tree. You need to treat that rubber first, because if you take the sap from the tree, the rubber tree, getah sekerap tu, you buat tire. If you use that as a tire, then on the hot road, it will be sticky to the road. Okay, so normally what people do in order to make the tire, car tire, is that they take this natural rubber. Let's say the natural rubber is made of what? Polyisoprene. Okay, so we have discussed this before when we differentiate between synthetic and natural polymer in the early class. So polystyrene is something like this lah. Something like what we call? Something like this lah, polystyrene. The monomer, the repeat unit for the what we call? The polyisoprene lah. So the natural rubber is by itself is like this lah. It's like this. It's like this. It's like a thermoplastic. Okay, but in order to turn this natural rubber into tire, what you do is that you add sulfur. You add sulfur. You add sulfur plus sulfur. Sulfur. When you add sulfur, what you get is something like this. Something like this. You have something like this still, but then the sulfur will cross-link. So you have sulfur here, you have sulfur here, you have sulfur here, you have sulfur here, you have sulfur here. So now this look like the thermoset structure, right? So car tire is thermoset. Thermoset. And natural rubber here is basically thermoplastic. So you can turn the thermoplastic into thermoset in this case by adding the sulfur. This thing, you add the sulfur to the natural rubber, the process called vulcanization. You make the natural rubber harden. Okay, so only then you can be very useful to make a tire lah. But of course, because it's thermoset, you cannot recycle back. So if you look here, so the problem nowadays is that you have the car tire dump. Car tire dump. Okay, you can see they cannot melt this thing. So this is the issue nowadays. I mean, they put in the what we call the big landfill, but they cannot do anything. They cannot melt it, whatever. They cannot reuse it back. So this is like a pollution, kind of pollution. It's not like they just put it because they want to put it, because they cannot melt it. They cannot do anything with this thing. So typically what people do is that instead of just put in the landfill, they crush this tire into the small crumb, car tire crumb, pavement crumb. They make this thing. They make apa? They make crumb. This thing. Sometimes they are make using the recycled tire. Recycled tire here is basically they have the tire that they cannot mold again. They chop it into small crumb, and they make a pavement out of that. Okay, so that's how one way they can solve the issue of what we call the landfill occupied by all this car tire. So they make it like a pavement ni lah, pavement, recycled pavement crumb lah, crumb rubber. Put here. Okay, so that's crumb rubber. So if not, they just need to be like this lah. Okay, so that is about what we call about the car tire. Car tire is also example of thermoset. And the last example for thermoset is phenolic. Phenolic compound, or other word is formaldehyde. Formaldehyde. This is another example for thermoset. So example of the material that made from this phenolic is bakelite. in the early class, in the first class, I asked some of you to present in front, and some of you present about the backlit. Backlit. So backlit is one of the first synthetic polymer produced by human. So if I put here backlit, backlit phone. So you might recognize this type of, not here. Backlit phone. Okay, some of you might recognize this old phone. Okay, so this thing, this body of the phone is made from the backlit, and the backlit, what we call is basically a phenol formaldehyde. So it's very hard, and it's a thermoset. Okay, another example for compound, the thing that use phenol and phenoldehyde is snooker ball. Snooker ball or billiard ball. Billiard ball, that also made from the phenolic compound or phenol formaldehyde. So we learned today we learned a few type of what is thermoset and thermoplastic. We learned some of the example of thermoset. First we learned about the polyurethane, and then we learned about what we call the epoxy, and then we learned about the super glue, and then also car tire is also example of thermoset, and also we saw that phenolic compound also a kind, I mean that it's a thermoset polymer lah.